So today's class we'll continue with whatever we have stopped from yesterday. So we were discussing about the data visualization part, exploratory data analysis part, right? So here we'll continue with that. So just we took some random data, we generated some random integers, and we were actually plotting the graphs, and we were exploring the options yesterday in the yesterday's class. So now instead of that I have so I have given you some CSV files. So cardio good fitness something, so some data you have with respect to some sort of exercises, cardio exercises, with the respect to fitness level, and how many miles that you are going to burn your calories. So based upon that, what would be your fitness, how it's going to be classified, and your fitness level is also going to depend upon your educational status, marriage, gender, usage, fitness, and so on. Okay, so this is the data whatever you have. So I have sent you here, so I have the data here. Look at this. If you go here, so you have to upload the data here. What you have to download whatever the data I have sent you. So then you have to upload. So already I have. I will search it. See, look at this cardio. So this data I already have. So where is this cardiovascular? No, cardio fitness. Okay, 1, 2. Yes, cardiovascular fitness. See, cardio good fitness CSV. This CSV file I already have, so I am able to read it here. So I will call that as a data pd.read CSV. So inside that I will just copy paste that, whatever the name is there, you just copy paste it and put it here. So you will get this. Okay, so you will be able to read the data. So it contains around 180 rows. So just for exploring few more data visualization part, so we'll complete EDA, exploratory data analysis today, and if possible we will go to linear regression if time permits. Okay, so look at this. You have product. So I have different types of product. Look at this, look at the approach. Okay, so I have different types. See, TM195 is there, you have TM798. So looks like, so there are various products, and people with different age, gender, education, marital status are using different types of product to burn the calories. So some miles and fitness, income, so many things they have given. So let it be. So what happens here, in case of your cardiovascular fitness, so you just want to look at the data, how it is looking like. So you just want to see what is there. So you do, so data dot is null dot sum. I'm checking if there are any null values. So data dot is null dot sum. So no null values are there. This is the head. This is the first five rows. So similarly, if you want to do for data info, instead of that, so if you want to go for last something, if you want to check for last 50 rows, you can check. So last 50 rows, data dot tail, last 50 rows it will come. Whatever way you want to check, you can check it, or you want everything, you want to check everything, you check it. Okay, last 50 rows I was able to see. So data dot info. So look at this. If you look at the data, see, once you click on data dot info, it's a pandas core frame. It's a pandas core frame class. So inside that it's a data frame. Yes, it's a data frame. How many range? 118 entries are there, 0 to 179. Yes, total columns how much you have? you have 9 columns. Yes. But the data type of each 9 columns it is given. Look at this product. Product is the column number 1. This is the product. So what is this? They have product codes there. 180 non-null object. So it's an object. It's a it's not an integer, it's an object. So age in integer, age is in integer. So similarly you have gender as object. So like this you will get the data type you are going to get. So data.info. So everything you are going to get it. So similarly check for null values, head and everything, tail already told you. So if you want to go for data.describe, you can go. Include all means if you are not going to give, see why I am giving like this. So if you don't give data.describe, okay, something like this, see what happens here. See, it will consider only those. Age is a integer. Education, see, look at this. Education is actually, it is given here in terms of numbers. Actually education will not be in terms of numbers. Maybe here in this data they have studied 21 years, 18 years, 16 years, something like, maybe I am guessing like that, it would be like this. So it's a number, usage number, fitness number, income number, miles number. So the data which are integers or float, only that will come. The data which is in the form of an object, that is not going to come. So if you want everything to be included, so you have to include all. So what is going to happen here? So data.describe, include everything. So if you, when you include everything, so look at this, all columns got included. Even see, look at this marital status. So single, partnered is there. So gender, male is there. Product, this is also object. Marital status is also object. The gender is also object. So what is happening here? Even though it's an object, it is coming here. But thing is that, look at this, marital status, count, it is counting. 2, unique, either single or partnered. So most of them are partnered, so that is top. And frequency 109 out of 180, 107 are, 107 of them are, most of them are partnered. But look at this, since they are objects does not have mean value, objects don't have standard deviation, minimum value. Wherever objects are there, you will encounter nan values. You cannot, because you cannot do any mathematical operation on the objects. You cannot do any mathematical operations on the objects. That is why by default it will remove, by default what happens, it will remove the those columns where the data types are objects. Okay, so anyhow we don't want to include everything. Okay, so let it be in this way itself, no issue. Okay, data info over. So that is simple data, very if data is like this, if the data is given to you like this, you will be most lucky, or anybody who is going to be working is going to be most lucky. Why? Because nothing is there, simple data, no null values, and everything looks like perfect. And if there are no null values, you will be happy, and no nan values to encounter, no need to do anything. Okay, so directly you can deploy machine learning. Okay, just give me 1 minute guys. Okay. ಹಲೋ ಅಣ್ಣ ಹೇಳಿ. ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಅಣ್ಣ ಹೇಳಿ. ಒಂದು 2-3 ಜೊತೆ ಡ್ರೆಸ್ ತಗೊಂಡೋಗಿ. ಇಲ್ಲ ನೀವೊಂದು ಬ್ಯಾಗ್ ತಗೊಂಡು ಡ್ರೆಸ್ಸು, ಸೋಪು ಇವೆಲ್ಲ. ಮಾಮೂಲು. ಆಯ್ತು ಅಣ್ಣ, ಆಯ್ತು. Sorry guys, so you have to go for, if the data is given like this, obviously you have to go with, in reality the data is not going to be like this. This is simple data, for our analysis, or rare cases the data will be like this, everything will be fine, perfect, because real time data, sometimes data will be coming, sometimes data will not be coming, sometimes you'll get, sometimes you won't get, sometimes you encounter null values, so you have to do something for that. Okay, anyhow, I'll explain that as well. So as of now you just look. So now next is I'm going to yesterday, just after this, what is that you have to do the, so what I'm doing here, I'm looking at the data, I'm analyzing the data, what is there in the data, I'm checking for the null values, I'm trying to describe, I'm trying to see what is the data structure, what is the data format it is there, whether it is in the string format or object or a boolean or a numerical value. Okay, so after that I start plotting. So I'll start plotting. So for starting plotting the graph, you have to import the libraries. So this is by default, all this you have to, by default you have to import Seaborn and MatplotLib. So histogram, see histogram, what is histogram? Yesterday I told you, can anybody tell me why I use histogram?
To check distribution.
Checking the
Distribution.
um, checking the distribution. Here how many numerical, see here you have this usage, witness, income, miles, they are integers, education is an integer, age in the data is stored in the form of integer. So if you do just data dot hist, and if you give your figure size whatever you want to give, so if you just give data dot hist, it will plot the histogram of only numerical, because if the data is numerical, only for that numerical data only I can check the distribution. Histograms checks the distribution. So look at this, histogram is going to check the distribution. Yes, it is plotting. Yes, look at this. So now if you look at the data, okay, I just don't want. Okay. So if you look at this data, first one age, if you look at the age, just refresh. See, look at the age. So age is something like, so do you think the data, most of them are 25 years, between 20 to 30 years, that is what the data is telling us here. And education, most of them are at 16 years, who have studied for 16 years, most of them. Similarly, usage, most of them is with the 3 and 4. What is that 3 and 4, we will see. And then fitness, what is this 3 and 4? Go to the 3 and 4 usage. Where is the usage? Usage 3 4. What is this 3 4? We have to look into, we don't know, that's a code. Okay. And income, people, look at this, people who have a lot of money, they don't have time to do exercise, they don't have time to do cardio. And obviously they are not doing any exercise. Most of them mid income, so they are the one who is actually wants to maintain the health, right? So similarly miles, so most of them 50 to 100 maximum, 50 to 100. So the 50 to 100 miles, they are able to use this product TM195, whatever the product code is there. So most of them are using for how much? Look at this, 50 to 100. So like this, so you can see the distribution, and looks like data is not, there is not much skewness, there is no, okay, data is okay, so you need not do anything, you keep it as it is. We'll keep it as it is. We will not do anything. We'll keep it as it is. So whatever, see, these things came into my mind, I am plotting this type of plots. Okay. It is not, there is no rule that whatever I have done here in the same way you have to do with the same data. Data will be given to you, whatever plot you want to plot, you can plot it and see it. So I am just SNS dot box plot, I am plotting box plot. I am plotting the box plot. See, look at this. In box plot x axis, y axis, I am putting data is equal to data, because here also I have stored it as data only. Data is equal to, here also I am giving data only. Y product, see, now you have inside this product, look at this. Inside this product you have TM195, you have TM798. So different types of products are there. Product versus what you can do is product versus income. So different product, so income is going to be a continuous value and product is a categorical value, because you have different types of product here, and which income people will use which type of product. So let us check that. So look at this, you can segregation possible here in data visualization. Here is distribution of jingles. So similarly, look at this, TM195 income people, $40,000 to $50,000 per year were earning. That is their choice. People with were earning more, up to $1 lakh per year. So look at this, they are preferring TM798. Maybe what special features it might offer, some special features, I don't know. Okay, so look at this. So you can segregate the things, and most of them are in this range, 60,000 to 90,000. So like this. Now similarly, what is this? Age. Look at this, let us plot age versus product. What type of, see, most of them who do exercise are youngsters only, within 35. After that, everything, no one is going to care about their body. Everything will be over, marriage will be over, and work will be over. They are not going to roam much. They are going to settle somewhere. They are not interested. So obviously, that is going to happen irrespective of their marital status. What happened here? Box plot. Okay. So look at this. Depend upon their age, whether irrespective of their income, youngsters are using the product, and most of them are between 18, 19 to 33, within 35 years. See, that too within 35 years, right? So like this. And similarly, if you want to check for marital status, okay, check for marital status versus age, or versus whatever you want. I want to check product. Let us check the product versus the marital status. So I will put this here. So now you see, you observe carefully, all of you observe carefully, whether the output will come or not. You see, I am getting error here. Why error, you tell me now? What is the problem with whatever I have given here? Anybody can guess why I am getting error?
Both are objects.
Both are,
Both objects.
yes, very good. Both are objects,
Hmm.
right? See, box plots are used whenever you want to plot an object versus a continuous variable. See, products, there are three different products are there. These are objects. Versus age is continuous. Here look at this. Products, three different products. These are objects. Versus income. Income is a numerical continuous value. So then only you can use box plot. You cannot use box plot like this. Marital status, either single or partnered or divorced. This is an object. What is product? Product is also different types. So both are objects. How can you plot? It's not possible. Type error. Neither x nor y variable appears to be numeric. One of them should be numeric. So I'll put one numeric value. So what I'm going to do is, I'm going to do one thing. I'm going to put here income, or yes, let us put income in the y-axis. So I'll put income here. I'll put income and income versus marital status. Obviously, as per our knowledge, people who are partnered, their income should be higher because they would be having higher experience, more age. Let us see. Obviously, look at this. People who are single, look at their income, and in general aspect I'm speaking. People who are partnered, so once they are settled, they are having higher income, they get partnered. So look at this. Obviously, so like this. So similarly, that is about the box plot. Okay, already I have done this. So cross tab requires minimum two positional arguments, index and column. So what is happening here? Cross tab, let us discuss this cross tab later, not now. The index you want. Okay, so similarly, look at this. You want to count, see, gender, see, I want to count. See, if you want to count something like this, product count. See, if you want to count the product, so table name, data. So what is this column name? Column name, you have this product. So what is this product? Yes, product. So product, so you will give it as a product here also. Same way here only I have given the gender na, so same way we will type it as product. So dot value counts. So table name, column name, dot value counts will give you so unique products or unique features that is present in a particular column. So that is going to give you unique features in a particular column. So I'm going to store that as a product count. So look at this product count now. See how much product counts, how many products in this product. TM195 there are 80 products, TM498 there are 60 products, TM798 there are 40 products. So you should know. So in this survey, out of 180, 104 of them are male, 176 of them are female. So like this. So you can use this. Okay. Similarly, look at this. You have if you want to do some pie chart, want to plot some pie chart and do some analysis. So this is a pie chart, plotting the pie chart. See plt.py, gender counts, labels. See this is a plt means matplotlib. So if you want pie chart, SNS is not sufficient. I have already imported this matplotlib. I have imported matplotlib.py plot as plt. Okay, so percentage matplotlib inline. So all these are imported properly, then only you will be able to plot this pie chart. So plt.py inbuilt. So pie chart. So you want gender counts. So instead of gender counts, what I will do is product count. So let us copy and put it here. Product counts, paste. Labels is equal to product count dot index. So title I want to give proportion of gym goers by gender. So I will say proportion of products used. Okay. So similarly, so look at this. Let us see. See, this is what happened. Yeah, product count you got, proportion of products used, TM79 22%, 33%, 44%. All these things you can do it in your Power BI or your Excel or your what is that, Tableau, or whatever the reporting tool you have. There, this I am doing data analysis here. This is a simple data analysis what we are doing here. So we are analyzing the things from the data from simple CSV file. Only 180 rows we have that time, but actually you will be having huge data. So this is a simple pie chart. So similarly, if you want similar to pie chart, if you want what is this pie chart, hollow chart, something like this. If you want something like this hollow chart, right? So instead of gender, use product. So dot value counts. So look at this. So this I am going to, already it is there now. Product counts. Where, here only I will change. I will just, already there. I am changing, that's it. PRODUC product na. So product count, product underscore count. So label, let us see whether it's going to work. String literal product count. Okay, line 6. Okay, no problem. Let us store this as product counts. Product dot value counts. Okay, what happened? Line 6 plt dot title. Okay, line 6 should come. Gender counts, where is gender count still? So this is product counts. Okay, so this is going to work like this. See, proportion of products used. So something like this, say whatever way you want. See what I am using here, display I am plt dot plot. So I am using wedge proportion. See, these are all see, you these things you cannot remember, don't worry. Okay, this auto percentage PCT, start angle 150, wedge proportion. This is auto PCT, start angle 150. So wedge proportion is not there. Whenever you use wedge proportion, it will give a hollow chart, something like this. Okay, so all these things, whatever way you want, you can do it. You can plot a bar graph also. So instead of that, if you want to do it something like this, see, it's a bar graph, you will get a bar graph. So that is a box plot. Now pie chart, we looked into histogram. After histogram, we looked into box plot. After box plot, we looked into pie chart. After pie chart, we looked into hollow pie chart. And now I am looking into bar graph. Same values, same product versus count. X axis product, y axis number of counts. I am going to take it. Okay, for that you have to define the value counts. How much in that product, how much value counts are there, that you should define. This product counts I am passing here. Dot values, color whatever you want. Means there is a whatever comes to your mind, you cannot give like that. Some standard colors you can give. So you can give some red. Okay, so something like this. So let us see. See, number of participants by product, you are able to get it, bar graph. So data analysis, data visualization, exploratory data analysis I am doing. Exploratory data analysis in the sense I am exploring the data, whatever it is there in the data, how it is behaving, what is happening, because I am focusing on products, because I am looking at the performance of my product, cardio fitness products. These are 3 different cardio fitness products. that are used across gender, that is used across income groups, that is used across different people. Okay, so that is why I am looking, that is why I am using products everywhere. Simply, that's a common sense. When data is given to you, which parameter you have to choose, which you have to analyze, that is left to you. You have to think and you have to apply what I have to do, what you have to identify. People will just give you the data and run away, and they are not going to tell what should be the output. Sometimes you have to figure out what has to be done. You have to figure out everything. If sometimes everything is predefined, specifically told, then it is fine. Otherwise, you have to analyze, you have to check, you have to sit, take the data like this, plot the graphs, analyze, establish, prepare a report. After each graph, prepare some what is that, inference, write the inference, then you present it, and then that is a part of data analytics process. That is part of data analytics process. You can say, what is there in this, sir? Already Excel people. Yes, Excel people are doing, already Excel people were doing this. Already people were doing, plotting the graphs. Yes, preparing any, this is a part of doing any project. Graphs, graphical analysis, data analysis will be there. It should be part of that. Okay, so similarly, count plot, directly you can use count plot also, bar graph and all instead of that. So sns.count plot, gender versus product. So now you see, count plot is used for both objects. Gender is also an object, product is also object. So where you have to use which type of plot, you should be aware. Simply you cannot plot any plot and error is coming and you are asking, error is there, sir, graph is not getting plotted, code is correct. Yes, code is correct, but you where which type of graph you are plotting when, that you should be knowing, right? So here both of them are categorical. So now how you see products, three different products used across the gender. See, male, female, irrespective of whatever it is, male, female, TM 195, both of them are using. Male is also using, female is also using. Only TM 798, female, they don't prefer this product. Most male it's okay. Male, they're fine with any type of product. Female, I don't know. As per the data, that is what data is saying. They are not comfortable with TM 798. So look at this. So there is a, so these analysis, these micro analysis you have to do with the data. This micro analysis you have to do. You are extracting some insights. We are extracting insights from the data. So that is your job. Data analytics, that is your job. Data engineering, data pre-processing. So before doing machine learning, all these things, this is optional. Again, it's an option. See, thing is that there is no rule that you have to do the data. No one is going to tell you. No one will tell you to do it. They will give the data and they will go away. Your job is, if you are actually following some procedure, you have time, please do EDA. Please do EDA, exploratory data analysis. You should do. If you are not going to do, you are unable. See, if once you do, you will understand the data, what is there in the data. Somebody asks questions tomorrow, you will be able to tell them, you will be able to show them. So that is the thing, that is the advantage of EDA. EDA should be carried out if time is there, and if it is an urgency, no need of, you can sometimes, EDA is going to be taken care by some other person, maybe Power BI person or other person. They just ask you to do some sort of analysis or machine learning. Some parts you can skip, not all, some parts, some graphs, some unwanted things you can skip it. Okay, okay, that's up to you. Again, there is no rule, thumb rule, you have to do like this only. Okay, but if you ask me, do EDA, my suggestion, do EDA first. Similarly, you have one more option like cross tab. So pd dot cross tab, look at this, inside pandas you have one option called as cross tab. So here this is the table name, this is the column name, product, again table name, column name. See, here also cross tab, this is also categorical, this is also categorical. Count plot, categorical, cross tab, categorical. This also you can use cross tab dot plot, kind is equal to bar, stacked is equal to true, figure size, so color, whatever you want you give, so pink and blue I have given, so label, x axis I am labeling product, y axis I am defining the count, okay, count of the product. So what I am passing here, so crosstab dot plot, crosstab dot plot, kind is equal to bar. So data I am passing product, and I am also passing the gender here. I am also passing the gender. So first I am passing the product, that will be given in the x-axis. That is going to be counted with respect to what? With respect to the gender, it is going to be counted. So now you see, if you don't want pink, you will say orange, orange and blue. Something like this. See, this is the pd.crosstab. We got like this. So you are able to get, see, the distribution of male, female, male equally using TM195, equally using TM498, but most of the male is using, because male is black color, most of them are using TM798. Female is not, very few of them, most of them are not interested. So like this is the use of crosstab, categorical versus categorical. Categorical means this is a object and object. So you can analyze by using the function called crosstab. Similarly, you have pd.pivot table. This is one more. Pivot tables you have na in Excel, you have studied pivot tables. Anybody? Anybody studied pivot tables? What is pivot? In SQL or Excel somewhere? Studied or not? No. Okay. So look here. Any doubts are there? Please ask me. I will stop. I will explain. Don't simply listen. Okay. So PD means pandas, pd.pivot table data. This is the same data. See, product again gender. Product versus, see what is happening here. Pivot tables are used to extend. How many products you have? 3 products you have. What is these 3 products? TM195, TM498, TM798. And what type of gender you have? Male and female, male female, male female, male female. And male female across age, male female across education, male female across fitness level, male female across income, male female across marital status, male female across miles of calories burnt, male female across the usage versus product. So look at this, all wherever nan values are, see you encounter nan values. Why you are encountering nan values? Age. So you are in, sometimes you are encountering non values. Why you are encountering? So we will encounter these non values because we are see, look at this is a gender, male versus male. This is whenever you are going to encounter a non values, obviously they are dealing with some not a numerical data object. So obvious. So you will get pivot table something like this. If you want, you can check and see. Anyhow, that's up to you. So max value, see data dot max product, in the product column, most of them are using TM798. So in age, most of them are 50 years old. Gender, most of them are male. Education, most of them. What is this? Not most of them. Sorry, I am telling you, you are listening. Maximum product, maximum number is TM798, maximum age is 50, gender, see, male, MALE, that is as per the ASCII value, ASCII records, male M, F starts with, after F M starts, so this male is going to come. Education 21. This is the maximum value. So usage 7. So wherever the maximum values are there, that will come. Minimum values, maximum, anyhow, if you want. So yesterday I told you pair, one command, all plots will come. SNS dot pair plot. Seaborn is called as imported as SNS dot pair plot. So inside that you pass on the data. So now you see age versus see there is a principal diagonal. See, I will show you. See, look at this, the one that is dividing. So my cursor is moving. You observe that is the principal diagonal. So now you see how. See, if you see this one, let us observe only one figure. What is this? Age versus what is this? So let us say. So this is age versus last but one, income. So look at this. There is a trend. You observe the trend here. So income and the last upmost column age. So there is a positive, so it is going in this direction. As your age is going to increase, your income level generally is going to, your income is going to increase, correct? So look at this positive trend. There is a trend. So something like, if you see this scatter plot, these are scatter plots, right? So if you see this scatter plots, something like this, they are not which are the data points are there everywhere. There is no trend. You cannot conclude anything from that particular graph. So if you are seeing something like this, input increases, output also increases. And you see this graph here in pair plot. You see this graph. You can fold this on the principal diagonal. Say you can fold it. You can fold it and keep it. Correct or not? You can fold and keep. So possibilities are there. So like this, so you encounter. So it's you can get the all types of graph at one shot. This option you don't have in Power BI. This option pair plot you don't have in what is that? Excel, advanced Excel. This option at a time you show me how is there any option where all plots can be plotted at once? So many plots. Here I can plot so many plots at once. Even in Power BI tab I have not seen. As per my knowledge till now I have not encountered. Excel not possible. So this is the advantage where Python MatplotLib Seaborn library that is having in our Python. So we can use it. So look at this age versus miles, age versus miles, education versus miles, usage versus miles. So each wherever see miles number, income number, fitness number, usage is also number, education also given in number here, age is given in number. Number versus a number, all numerical values whenever you plot the pair plot. Look at, should keep remembering, whenever you plot the pair plot, all the numerical values will be plotted. It will automatically eliminate. It will not take those data where there are objects. See, for example, you have gender. Gender is not there here. Where is gender? Gender is not there in pair plot. It will not take. So automatically it filters, automatically it plots. So you'll get some fair idea. Right? So that is about this pair plot. Similarly, you can you can plot the histogram with the help of histogram. You want distribution. Distribution means it should be gender. Gender means one value should be numerical. So income, distribution of income versus the gender, by gender. Distribution of income by gender. See, irrespective of whether it's a male or a female. So people who are young, most of them will earn between $40,000 to $60,000, and later, look at this. There are few males who are very much successful who is going to earn. So that is the case. So you can plot. You can similarly, you can instead of gender, if you want product, so keep product here. Product. So product by income. So So look at this. Yes, you see, whatever you want you can plot. So similarly, distribution plot, histogram is also used for distribution. Okay, similar way, directly you can use you have one more option in this Seaborn called dist plot. Dist plot is also a type of histogram only, but it's going to give some more in-depth analysis. For example, age, distribution of age. So if you plot the distribution of age here, see, look at this. What is happening? See, it is along with the bar graph. It is showing you the curve, how the distribution. Most of them are between 20 to 30 years who are using this cardio fitness product for burning calories. So most of them are 20 to 30. So distribution plot. So box plot, distribution plot, count plot, then what is that plot? Pie chart. So pie chart, then histogram, then pair plots, series of plots, then cross tab, all this, so many plots. But then you have used this also. What is this? Product counts also, bar graph, bar plots. So all types of plots. See, whatever so many plots we are able to cover today, right? Similarly, the same thing if you are using, see here, distribution, gender distribution and histogram, both of them you are used. One should be numerical value and another should be categorical, that you can compare, or simple numerical value also can be plotted for distribution plot. But in case of your count plot, both of them should be category. In case of your box plot, one should be numerical, one should be category. Okay, so similarly, so that is about your data visual. See, now you have one more option called as, see, now you look at this carefully, core. So data core, so this is core, data core. So SNS dot heat map. So you have one option called as heat maps. So what is a heat map? That I will tell you. Okay, correlation. CORR means correlation. Data, already this the file, the name of your file is data. Data dot core. So if you use this data dot core inside this pandas or Seaborn, and you can plot that in SNS dot heatmap. So let us say change the color. See, now this is the just like how pair plot happens, here also heat maps can be plotted. Heat maps, what is happening here, all numerical values, age is a number, education is number, usage is number, fitness, income, miles, all these are numbers. See, these are all principal diagonal. See, age is related to age 1, education is related to education 1, means let us say if age is related to fitness, it is 0.061. Okay, education related to usage 0.4, yes, maybe to some extent. Education related to, yes, 0.63, yes, people who are educated most likely to have little bit of higher income, maybe, that is not 100%, that is 0.63. See, and color codes, and now you can see what is this, how this number got assigned, what are these numbers, and what is the significance if it is 1, and what is the significance if it is nearer to 0. Anything that is having a strong correlationship, those correlationship value will be nearer to 1. Okay, so look at this, anything above 0.8, correlationship value above 0.8 or above 0.9, that value will be having, see, for example, income and education, what is the correlationship? 0.63. 0.63 is positive correlation, it's a positive value, greater than 0.5, greater than 0.6, 60%, 63 means 63%. There is a 63% chances that people who are educated, they are most likely to have their income is most likely to be dependent upon their education background, right? Similarly, something like this, or So based upon this they are going to code this color. Okay, so I think this code color I have to will change it. Let us change this. Why? Because I'm not comfortable with blue. Okay, so all these are inbuilt methods. So on cool warm, let us say cool warm color map. What is this color? Let us check. Cool warm. Okay. Okay, so now it looks fine. So you can check the heat map, something like this, different correlationship. So see, look at this 111 strong. Based upon this, it's go. So how this correlation is calculated? What is this? A part of statistics. See, what is correlation? When the correlation is strong, when the correlation is moderate, when the correlation is weak, how you are going to say that? How these heat maps are? This is a simple command. SNS dot heat map. Heat map will be plotted, but how it's actually gets plotted? What is going to happen? For that you have to understand little bit of statistical theory that I am going to tell you on tomorrow, not now. Okay. So what is a correlation? How correlation is calculated? What is Spearman correlation? What is that? Manhattan distance. So different types of correlations are there. That type of correlation, see for example, you will see, just I will show you different types of correlations are there. So why I want to I'm stressing on this, because you have to know which one is strongly correlated and which one is weakly correlated, which input, which column is correlated to which column, or which column is correlated to the output stronger. Because I want to check the correlationship. See, here you have correlation. Let us assume some dull color is there here. So 0.015, this is the weakest value, 0.015. What is the 0.015? 0.015, it's usage with respect to age. So age and usage is nothing to do with usage and age. So their correlationship is very weak. So I cannot consider. So while I can drop those values where correlationship is very weak. I can drop those columns where correlationship is very weak. Okay. So you cannot drop. You have data. You have 12 columns, 13 columns. You say no sir, I will take only 8 columns. I am dropping 4 columns. I will ask you why you are dropping 4 columns. No sir, the correlationship is weak. Wow. How correlationship is weak? No, I plotted the heat maps and so I checked the correlationship. I think even if we drop these columns, nothing is going to happen. Still our machine learning model is going to work. So like that. So in order to keep the features or eliminate the features, we check for correlationship. Okay. So how these correlationships are calculated, that we will see tomorrow. Okay. So look at this. These are the different types of correlationship. So you have positive, negative, or different types of correlationships will be there. So tomorrow we will see. Whenever the trend is like this, strong positive correlation, trend is ulta negative correlation. Whenever it is something like this, no correlation. So we will discuss this tomorrow. Don't worry about this as of now. So like this, similarly pivot tables, I already told you about pivot tables. Whatever the way you want, you can plot it, the pivot tables. Okay. Then crosstab also I have told you. So this is one more another data, just like cardio data, this automobile CSV data, same data analysis we have done. Okay. So here in data analysis, see, look at this one more plot I have not told you. This plot I told you, joint plot. You have this SNS dot joint plot. Look at this engine size. See, this is the data you have. You have 26 column. I'll send you the data also. You can check, do the data analysis today. Sit and do the data analysis today. Here, look at this. What I am checking here in the joint plot, engine size versus the horsepower. Horsepower means the output, torque output that you are going to get from the engine. So the engine size, I am checking upon the engine size with respect to horsepower. See, look at this. Engine size 50, 100, 50, 250, 300. What is the horsepower? How many kilowatts or how many HP? 200 HP. How it is varying. So look at this, engine size is increasing, horsepower is also increasing. Obviously, heavy vehicles, engine size is going to increase, horsepower is going to increase, obvious. So you can use joint plots and you can see something like this. So different types of, this is pair plot already you know. So some other plots like you have strip plot, you want a different design, strip in the form of strip, gas, diesel. Fuel type, you have two types. In the fuel type you have diesel vehicles, your gas, the vehicles running on gas, and versus the horsepower. This is the table name, auto is the table name, this is the column name, horsepower. So strip plot, swarm plot, this will be in the form of swarm. So box plot, normal box plot you already know. So all these things you can explore, guys. Okay. So bar plot also I told you. Bar, one is numerical, one is categorical. Body style is categorical always. Horsepower, it's a continuous value always, and based on that engine location. Now you see engine location front rear versus horsepower versus, see, two categorical variables, two objects. Body style, you have different body style, convertible, hatchback, sedan, wagon, hardtop. Body style versus engine, whether engine is mounted on the front side or the engine is mounted on the rear side, that is also object. Versus horsepower, horsepower is continuous power output. So horsepower versus horsepower. See, three variables analyzed at a one graph, possible. Three variables analyzed in a one graph, possible. So three, so that I can plot. So similarly here also look at this front rear, same, versus instead of horsepower, body style and engine location. That's all. So all these things you can do it. Point plot in here we are not going to use, just for your information. I am not comfortable with point plots because anyhow we can't draw much, it looks like complex. And similarly LM plot, all these are different plots, guys. Yesterday and today we have discussed about exploratory data analysis, data visualization. This is part and parcel of data analytics. Before doing machine learning model, all these things you have to do. You have to check the data and you have to see what is happening. So I will do one thing, I will send this cardio fitness to you. So okay, so I'll send this document. You just don't run it, you have to practice. Don't practice in the same manner, explore your own way of plotting the things. What is this? Cardio. So this notebook only I am sending you, cardio fitness. Okay. So tomorrow, only tomorrow, guys. I'm sorry, now I have recovered to some extent. I can take classes from Monday. Okay. Unfortunately, I could not take offline class. Sorry for that. Not in my hands. So any doubts in data analysis, data visualization, exploratory data analysis? Are you able to explore Seaborn library?